Now we're going to talk about parallel and perpendicular lines. Now, parallel and perpendicular lines have very specific properties. Sometimes useful, sometimes not so much. And we're going to start out by defining what we mean by parallel and perpendicular lines. We're going to start with parallel lines. Parallel lines are two lines that never cross one another. They're the same distance from one another forever and ever, all the way through infinity. Now let's say that we have equations for these lines. We'll say the first one is y equals 2x plus 1. And we'll put them in slope-intercept form. That'll be important later. Y equals 2x minus 5 for the other. Notice as they're in slope-intercept form, their slope in this case is 5. So m is equal to 5. 2, pardon me. M is equal to 2. It's the coefficient of x here. Meaning it's going to rise 2 units for every 1 unit it's running. And so we're going to say that two lines are parallel. And the symbol for parallel are two diagonal lines like that. And we'll use that notation in a little bit. The two lines are parallel if they have the same slope. Which they do in this case above here. Now this next case are going to be two lines that are not parallel. They are what we call perpendicular. Perpendicular, for our purposes, means that they are going to be crossing exactly at a 90-degree angle. This is also called a right angle. We use that little box symbol there. They're crossing exactly at a 90-degree angle. Now, in this case, the one line is going to be y equals 5/7 x plus 2. The other line is going to be y equals negative 7/5. Now notice their slope x minus 3. Notice their slopes. The slopes are not the same because they're not parallel. They're perpendicular. They're what we call negative reciprocals from one another. So we're going to say that two lines are perpendicular. Another word for perpendicular is orthogonal. That comes up occasionally in higher mathematics. But for our purposes, we'll just say perpendicular. The symbol for perpendicular are two lines that are perpendicular. It looks sort of like an upside-down T. And again, perpendicular lines means that the one slope is a negative reciprocal of the other. The way we'll represent that is we'll say if one slope is A, the perpendicular slope, and I'm going to use the symbol here, the perpendicular slope, sorry for my bad handwriting here, is going to be negative 1 over A, meaning it's a negative reciprocal, or the opposite, and it's flipped upside down. Let's go ahead and show you an example of a perpendicular slope. So if m is equal to 1/2, then the perpendicular slope, which I'll have the little subscript down here with the perpendicular symbol, is going to be the negative, flip it upside down, is just a 2. Let me show you another example. If I have m equals negative 4/5, then its perpendicular slope is equal to a positive 5/4. So just keep that in mind. What we're now going to do is we're going to talk about what if we're given an equation of a line and we want to find a parallel or a perpendicular slope, and in fact an entire equation. So we're going to say we want to find a line through the point 1, 5 that is parallel to the line y equals 3x minus 4. Well, this should be easy enough. We know that the slope of this line is m equals 3. So its parallel slope, I'll use the notation here, is also 3 because parallel lines have the same slopes. I'm going to go ahead and write y equals mx plus b. Here's my slope-intercept form. And I know m, I know y, and I know x. So I'm going to replace y with 5. Or let me go ahead and put the slope in here. So 3x plus b. And you'll note I don't have b. I'm looking for b, but I do have x and y. I'm going to plug that in and then solve for b. So 5 is equal to 3 times 1 plus b. 5 equals 3 plus b. Subtracting the 3, I get that b is equal to 2. So my parallel line is y equals 3x plus 2. That is my parallel line going through the point 1, 5. Let's do another example. But in this case, we're not looking for a parallel line. We're looking for the line through the point -4, 8. And now we want a line that is perpendicular to y equals 2/3 x minus 3. Now, we know that the slope of the line that we have, the 2x minus 3, is 2/3. So if we want a perpendicular slope, I have to take the negative reciprocal. That's going to be a negative 3/2. So the line I'm looking for is going to be y equals negative 3/2 plus b. And now I need to know what b is, or the y-intercept. So I'm going to use the point for -4, 8, and I'm going to plug that in and then solve for b. So 8 equals negative 3/2 times -4 plus b. Multiplying that out, I'm going to get a positive 6. So 8 equals positive 6 plus b. And then subtract the 6 from both sides. Gives me b equals 2. So my final answer is y equals negative 3/2 plus 2. There you have it.